Hi, it's your guy Olumide. Today we're gonna be solving another one of the most commonly asked tech interview question. Um, it's a DSA question and the name is evaluate expression. The problem statement states that given a string representing a mathematical expression containing integers, parentheses, addition and subtraction operators, evaluate and return the result of the expression. So I'm giving an example here as an input of s equals to this string of 18 minus open bracket 7 plus another parenthesis here, 2 minus 4, and then this. So if we look at it and just by visually looking at it, we can evaluate the inner expression 2 minus 4 to give us minus 2, and then 7 plus minus 2 will give us 7 minus 2, that's 5, and then 18 minus 5 is gonna give us 13, which is in the output now. So we are gonna be able to efficiently solve this problem and to return the result of the expression, just like in this case. At first, it might seem overwhelming to solve expressions that include negative numbers, numbers with multiple digits, just like this 18 right here, numbers with multiple digits, negative, and nested expression within parentheses, just like in this case whereby we have even nested parentheses inside this parentheses. So, and why it might look quite difficult at first is that it is a string. It is given as an expression, string expression. So to navigate multiple digit numbers, number containing multiple digits, to be able to navigate them, to convert them into an integer, to be able to navigate nested parentheses and negative number can look tedious at first. So the key to managing this complexity is to break down the problem into simpler, more understanding chunks. So let's first focus on simple expressions that does not contain parentheses. So something like this now as an expression that does not contain parentheses. Even in this expression, as simple as it is, there's already some complexity in it due to the presence of two different signs, the positive sign and then the negative sign. Like we can see here, this expression is a string of 28 minus 10 plus 7. So we see that 28 is a positive number while minus 10 is a negative number. So handling these two different signs can pose some challenges. An immediate simplification we can do right here is that we should take each number in the expression as a positive number. So even though we know there are multiple signs, plus and minus, that might be difficult to recognize because it is a string, but one way to simplify it is to take each number as a positive number, and now we are gonna assign a positive sign and a negative sign. So we will have the sign variable to be equals to 1 to represent a positive sign, whereas whenever the sign variable is equals to minus 1, it represents a negative sign, that is a minus, but sign equals to 1 will represent a plus. So what we're going to be doing is that now, depending on the sign that comes before a particular number, now we're going to be multiplying that sign by that number so it can give us the true value. So we are going to take every number we see as a positive number. Now, depending on the sign is going to be plus 1 by default. So now as we navigate the string and the expression, whenever we come across a number, we are going to multiply it by its preceding sign. So meaning that number, whether it is a minus 10, just like in this case, we are going to take 10 as a different entity on its own as a number. Now, because it is preceded by negative, so we are gonna change our sign. Our sign variable is gonna be minus 1 because it is preceded by a negative number, and we're gonna multiply the sign by 10 so that it could give us the negative 10. So, and similarly in this case now, whereby we have a plus, the sign is gonna change to 1, and we are going to take this as just a neutral 7, and when we multiply the neutral 7 by its sign, it's going to give us the true value. So that's when we can simplify conflicts in signs. So that's done. Now another complexity in this expression is that some number have multiple digits. So how do we process numbers with multiple digits now? So now consider this particular string 123. So it's a string of integer 123, right? Now we want to explain how we're gonna process numbers with multiple digits. So we are gonna first go into their first digits now, just like this. We use a pointer to navigate through the string. So when we come across the first number or the first element of the string, which is the first number, we're gonna create a current number, so which is gonna be set to 0. So this number is gonna help us to sum up each digit in the number. So it's gonna be initialized to 0 and set to 0 at first. And what we're gonna be doing is that we're gonna say 10 times whenever we come across a new number in the string. I mean, when we're iterating through the string, just like now when we come across 1, we're gonna say 10 times the current number plus the digit that we encounter. So if we look at it, our current number is 0 by default, and 10 times 0 gives us 0. 0 plus the digit, which is 1, will give us 1, right? So now that way, what we're trying to do in essence is that, fine, this is our new current number now, 1. Fine. When we go to the other elements in the string, as we traverse through the string now, we're gonna do the same thing again, 10 times the current number. The current number is 1 now so far. So 10 times 1 will give us 10, plus digits is gonna give us 12, which is digit is 2. So 10 plus 2 gives us 12. So what we're trying to do is that we're trying to multiply each of the number by 10, and then adding the digit to it. So in that case, we start from 1, we multiply 1 by 10 and add 2 to it, so that it will give us 12. Then we are going to take again 12, and we are going to take that 12 and multiply it by 10 again, so we can add 3 to it. So that is going to give us 120 plus 3. So that gives us 123. So that's how we can solve the problem of a number containing multiple digits in the string. So we iterate through such a number, and at each iteration we are going to collect the current number, multiply by 10, and add the digits onto it, and that's how we do it until we get to the end of the digit, the last digit. Now that we have a better understanding of how to deal with the positive and negative signs, as well as numbers that contain multiple digits, let's move forward by evaluating this expression here. So we are going to start off with a sign of 1. So by default we'll be having a sign of 1 and our current number, so to keep track of to help us to form and build up the numbers. So we're going to set it to 0 as well. Now upon reaching this minus operator, so really we have 28 minus 10 plus 7 as the expression. So, and we already discussed how to navigate through a number to build it up digit by digit, and upon reaching this minus, now we've gotten to, that implies that we've gotten to the end of the number 28. And what we're gonna do is that we're gonna multiply this number 28 by the sign. The sign is set to 1 by default, so we're going to multiply 28 by 1 to give us 28, and we're going to add the result, which is 28, we're going to add it to the results variable. So don't forget, the result will be a variable that will help us to keep track of the total, the total sum of the expression. So we're going to add the 28 to the results, and we're going to set our sign to -1, because now there's a shift in sign. It was plus initially, it was +1 initially, now sign is -1. I'm also going to set our current num to 0. Don't forget that it's currently at 28, but because we are about to start building another number, don't forget the operator is at minus. So what we're doing really is that we are going to be iterating through each of this expression, each of the string in that expression. Don't forget it's a string. So we want to evaluate the expression in the string. So we're going to be changing through, and now that we've gotten to minus, we're going to set our sign to -1. We are going to set our current number to 0 because we know that we've gotten to the end of a number. I want to start another number. So but before we set it to 0, we are going to save it. We are going to add it to the result by multiplying the current number, which is 28, by the sign, and then adding it to the result, which is what we did right here. So the result is 0 by default, and then the sign is 1 by default. So when we multiply the sign by 28, it gives us 28. 1 times 28 gives us 28, and then our result now becomes 28. So our current norm will be set to 0, and our sign set to -1 to build the next number. So now when the pointer gets to the next operator, now it would have built the current number to be 10, and then, so don't forget the sign is -1. So because it has gotten to an operator, that implies that it has gotten to the end of a number, so, and it's just about to begin another number. So we have to add the product of that number, which is the current number, and the sign, which is -1. The product of the current number and the sign will give us -10. We have to add it to the result. The result is initially 28, like you can see, and initially 28 is actually initially 0, but when we add it right here, we have 28, and now we are going to be adding -10 to it now. So, and that's going to give us 18. So at this point the result is 18. So we're going to set our sign to a +1 because the pointer is pointing at a add operator. So the sign will become +1 and the current number will become 0 because we're about to process and build another number now. So, and then by the time the pointer get to the it will get to 7, and it will get to the end of the string. It's gonna cut out of the for loop now. So, and doing that now, we are just gonna multiply the current number, which is 7, by the sign, which is 1, and then we're gonna add it to our results. That will give us 18, which is 18 right here. So 18 plus this 7 now gives us 25. Again, we're gonna set our sign to 1 and our current number to 0. So, and that's it. So we can see that 28 minus 10 plus 7 will actually give us the 25 here. Now that we can solve expressions that does not contain parentheses, which is what we solved here, we can now proceed to involve parentheses in our expression because the problem is going to be containing parentheses. So we just try to break it down so we can have a better understanding. So now we have what we call nested expression. A nested expression is an expression that is contained within its parentheses. So just like this now, look at 2 minus 4 right here is contained within a parenthesis, and we call it a nested expression right there. So in order to solve an expression like this 18 minus 7 plus 2 minus 4, to solve this problem we have to first solve and evaluate the nested expression before we'll solve the original expression. So in solving this problem we have to start from the innermost, this particular 2 minus 4, we sort it out into -2, and that's what we have here, that 18 minus 7 minus 2, and then we still have to sort 7 minus 2 before sorting this original expression of 18 minus 7 minus 2. So 7 minus 2 gives us 5, and then when we evaluate the nested expression we can then proceed to solve the full original expression by doing 18 minus 5. So this is how we'll be solving expression containing parentheses. We can therefore observe that a stack might be useful to help us evaluate nested expressions in the right order. So because we need to be treating this nested expression before actually treating this outer one, which is also a nested expression. Why? Because the expression is contained within the parentheses, before then treating this original expression. So we need a way to keep track of the current expression, the nested expression, so that we can sort that one out before sorting the original expression, and stack is good at doing that. So let's explore this stack idea to solve this problem. It is clear that an opening parenthesis signifies the beginning of a nested expression. So that's how we identify that this is a nested expression whenever we encounter an opening parenthesis, while a closing parenthesis signifies the end of a nested expression. So since we already know how to evaluate expression that does not include parentheses, just like something like this now, an expression that does not include parentheses, we already talked about that in the previous section. So now let's just start from, let us focus on what to do when we encounter an opening parenthesis. Now, at the first nested expression, at the first opening parenthesis where the pointer is currently, we know that a nested expression has started. So, but before we evaluate the nested expression, which is the 7 plus 2 minus 4, we really need to save the running results, meaning that the result that we have so far, including the sign of the upcoming nested expression, that is this nested expression that we are about to solve now, that start from the opening braces. So the sign that comes before it, we have to save it, including also the results, the running results. We have to save it so that we can fall back to them when we are done evaluating the nested expression. Don't forget that after evaluating the nested expression, we still want to get that result of the nested expression and to subtract it from the running result that we have here. So we have to store it inside the stack. So what we do is that we are going to push the result into the stack, which is the running result, just before we start the nested expression. We're also going to push the sign into the stack, that is the sign of the upcoming this same nested expression that we encounter now from the opening parenthesis, the sign that it bear, so that once we evaluate the nested expression, we can easily multiply that sign by what we push. We can easily multiply that the value that we get from evaluating the nested expression. We can multiply it with the sign that we are trying to push into the stack now, so we can obtain the correct value. So we are doing two things now. We are pushing the result into the stack, which is what we did right here, and we're also pushing the sign into the stack, so the sign of the upcoming nested expression. So that's what we have right here after pushing it into the stack. And after doing that, we are going to reset our result and sign variable to 0. So result is going to be equals to 0, sign is going to be equals to 1, which means positive. So because we are about to evaluate a new expression, which is the nested expression. So doing that, the next parenthesis that we encounter again is an opening braces, an opening parenthesis. Don't forget that earlier right here, the pointer is pointing at the first opening parenthesis, and once this is done, it's move on to the second opening parenthesis. And what we want to do again is that we need to evaluate this new nested expression. So, and to do that, we have to store the running sum, the running results, which is 7. So we have to store it into the into the stack again, as well as the sign. We have to save the sign also, which is a positive now, not negative. So we have to save it into the stack, so that we then reset the results and the sign variable to 0 and 1, so we can start to evaluate this new nested expression again. All this time I'm skipping the whole process of evaluating the current norm, multiplying the current norm by the sign, and adding it to the result, because we've talked about that. I'm just trying to focus on when we encounter an opening parenthesis, what we do in such scenario. So now, in a situation whereby we move away from the opening parenthesis right here and we shift forward, we evaluate 2 minus 4. We perform current number to build the number 2, to build the number 4. we sum them and add them to the new results. Don't forget that the result have been reset to 0, as well as the sign have been reset to 1, so that we can evaluate this nested expression. So now when we get to the closing parenthesis, this first closing parenthesis, it means that the current nested expression just ended, and we need to match its results with the outer expression. Now here's how we do it. We pop out of the stack, and don't forget that what is at the top of the stack is the sign. Look at it right here. This is the stack. It contains the sign. So when we pop out of the stack, we multiply that sign, either a 1 or a -1. We multiply it with the result, with the running result that we have from the current nested expression. So you see now the reason why we are collecting that sign inside the stack is so that when we evaluate the current expression, I mean the nested expression, now we could multiply it with that sign. So and that's what we did there. And when we multiply it with the sign, we have -2, because the result is actually 2 minus 2, right? This is the result here, 2 minus 2, 2 minus 4, and that's -2. So when we multiply it with the sign, which is 1, that have been saved in the stack, it still gives us -2. So and the next thing again that we do is that we add this result to the the result for the outer expression. Don't forget that the outer expression is 7, and before we go into the inner in the nested expression, we stack it, we push it into the stack, as well as the sign for the inner nested expression. So now we are going to be multiplying the result for the nested expression, which is -2. We are going to be multiplying it by 1, which is the sign 1, and then we are going to be summing it with the outer expression. And now we get the outer expression is by popping out of the stack. So when we pop out of the stack, now we then sum it with -2, which gives us 7 minus 2, which gives us 5. So that way now we are able to match the result for the current nested expression that we are trying to loop out of, because we have encountered the closing parenthesis. So the result so far, we are going to multiply it by its sign, which is just outside of it, this plus right here. And after doing that, we are going to sum it up with the outer expression, the outer result, which is 7, that we have saved in the stack. So doing that now, we move our index again by 1. So really, this is now the visual. Before we move our index again, this is just the visual. We pop out 1 and 7. So what is just remaining in the stack is -1 and 18. And then you see that now we have a general result for the expression 7 plus 2 minus 4. We have a general result now, because we have matched the nested expression with the outer expression, and we have 5. So doing this now, we are going to move our pointer to the last elements in the string, which is another closing parenthesis. So encountering another closing parenthesis, what we want to do is that we want to pop out of the stack again, having in mind that what we are going to pop is the sign. So don't forget that it is the sign for this particular is the sign right here, is the minus that we have right here. So is the minus that we have outside. So we multiply it with res, with the result. So I'm multiplying it gives us -5 here. So and what we want to do is that we want to add it to the results for the outer expression, which is 18, that we have added into the stack. So we perform another pop now from the stack, and we add it to the result, which is -5. So and then -5 plus 18 will give us 13, and that way now we see that the result for the whole original expression is now 13, and our stack becomes empty. So this is how we solve a problem, how we evaluate expression that contains parentheses. And now that we have reached the end of the string, we can just return the result res, which is actually a result for the entire expression. Now we are going to into the code implementation. Now let's move into the code implementation. We'll be calling our function evaluate expression, and we'll be collecting a string, which is the string of expression, and that's the only argument we'll be having. We'll be returning an integer, so which is the evaluated expression, the evaluated sum. So right now, okay, let me define the parameters we'll be using. So we'll be collecting the s like this. So right now, let's define the variables we'll be needing. We'll be needing a result variable, we'll be needing the sign variable, and we'll be needing the current number variable to help us to keep track, to help us to build the numbers. And their default, the initial value will be 0, 1, and 0. So we'll also be having the stack variable, so we should represent a list now. So, and we're gonna be iterating through our string for c in s. So for each string, so now if c is a digit, if it's a digit, what we want to do is that I want to build it up digit by digit. So we say our current num to be, we set it to 10 times current num plus integer of c. Right, so like we explained in the logic, this is how we can build it digit by digit, multiplying the current num by 10 and adding the digit to it. So that's how we can build it. And in a situation whereby c is not a digit, but probably c is a plus or minus operator, what we want to do is that we, when we are iterating through the element in the string, if we come across a minus, definitely there will be a number that come before the minus. Look at this, or a plus. Look at this now, we have 18 before the minus. Anytime we have an operator, there's always a number before it. So that number, first of all, we need to add it to the result, and before we add it, we need to multiply it by the sign. So sign times the current number that we build. So we're gonna multiply it, so we're gonna sum it up to the with the existing result, which is 0 by default. And after that, we can now proceed to set our sign. So don't forget that we come across a sign, so c is either plus or minus, so we set our sign to -1 if c is equals to a minus, else we just set it to 1. And then we set our current num to 0. So why we are doing this is because after a plus or after a minus, we are expecting to build another number, so we have to drop the existing current num. So look at this case now, the existing current num is going to be 18. So when we come across a minus, we want to build a different number, so we have to reset it to 0, so that there won't be a problem right here when we are multiplying the current number by 10. So it won't be multiplying an existing number by 10. So right after doing that, we have to check again that, okay, what if c is equals to the opening parenthesis. In a situation like this, we know we are about to go into a nested expression, so we have to save some things into the stack. So stack.append, we have to save the running results into the stack, and the same thing applies, stack.append. After pushing the running results, also want to put the sign for the sign of the upcoming nested expression. So look at this case now, whereby we have 2 minus 4. By the time we get to this opening parenthesis, we know we are about to go into a nested expression, so we have to keep the sign, so that the sign of that nested expression, we keep it into the stack. And after doing this, we want to set our result to 0, and similarly want to set our sign to 1. So why we are doing this is because we are about to evaluate a nested expression. So our result and sign so far, we have to neutralize them so we can solve the nested one. So if similarly, it will be good for us to set our current num to 0 now, so as to neutralize any previous current num, because we're about to build a new set of numbers, so we don't want the previous number to be interacting or interfering in this new nested expression. So right now, if c is equals to a closing parenthesis, we know that we just concluded the nested expression now. So what we want to do really is that we want to take the results that we have with this nested expression that we just concluded. We want to multiply it with the sign, and we are going to do a stack.pop because we saved the sign inside the stack. So after multiplying the results, just like here, let's say that we perform a 2 minus 4 now. So after performing a 2 minus 4, we want to multiply the minus 2 that we got from 2 minus 4. We want to multiply it with the sign minus, with the sign plus. That's what we did there. And after that, now we also want to add it up to the outer results that we had. So stack.pop. So what that one means is that, before we attend to this nested expression, we stack the results, the running result, which is 7, and the sign, which is plus. So we want to sum it up so that we can match the the result from the nested expression with the result from the outer expression. So that's how we are performing the second pop. Don't forget that right here we pop 2 things into the stack, so the result and the sign. So you need to take note of the order with which you are popping these things into the stack though. So anytime you perform a pop, the first one that should come out is the sign. Anytime that you perform the second pop, what should come out is the result. So why? Because we do it in that order. When we are appending into the stack, we append the result first before the sign. So sign will come out first before the result. So now after we pop out these two things like this, we need to really take into consideration a rare case, whereby, consider this situation whereby let's say our s is equals to this string now, 18 minus 7 plus 2. So when we encounter this closing parenthesis now, there is a particular value that we have within. So that value, we have to add it to the results. So okay, let me use this example now. So 1, or let me say 20 plus this whole expression. So whenever we evaluate an expression like that, we have to finalize the result, the current nested expression. So, and how we can finalize it is by, first of all, taking the result that we have here. So taking the result and adding it to sign times the current num. So doing this, we ensure that if there is a number that comes before the closing parenthesis, we will evaluate the sum of the number with the result, with the running results at that current expression, that current nested expression, before we pop out and before we do any other thing. So that we ensure that the evaluation and the calculation within the nested expression is complete before we multiply it by the outside sign and before we add it to the outer result. So, and by doing that, That's all we need to do, and then we just have to return. So at this point we simply return results plus sign times the current norm. So you might be wondering that why do we still have to multiply it by the but why not just return results? Well, let's consider a situation whereby s is equals to 18 minus 5. Imagine. So you know that normally whenever we are building a number, there's no much thing that we did there. All we just do is just find the current number and keep building the number like that. So whenever a number ends the expression or the whole string, we want to make sure that that number is multiplied by its sign and added to the result. So because actually if we not do something like this now, it will just return this 18. 18 is simply going to be returned. It's not going to take into account of minus 5. So we have to multiply, we have to add the result with the last current number and then multiply that last current number by its sum. So we have to do something like this so that it will take account of minus 5, so that it won't just loop out without taking account of minus 5. And that's why you will notice that we used to set our current norm to 0 whenever we encounter something like an opening parenthesis, or whenever we encounter something like a plus. So that way is to make sure that if the current number is not 0, definitely we have not added it to the result. Anyway, you see us adding it to the result, we only set our current number to 0 to ensure that that particular number have been considered, have been added in the result. But so definitely if it has been added, current number will be 0, and then it's just simply saying return results plus 0. But if current number is not 0, definitely it has not been added to the result, and we are going to add it before returning the expression here. So right now let's run this code and see how it goes. So we see that 13 is being printed here. This is it. So, and that's the actual answer to this problem. 18 minus, and evaluating what is inside first, that is 2 minus 4, it gives us minus 2, and 7 minus 2 gives us 5, and 18 minus 5 will give us 13. So thank you for watching, and please do like, subscribe and follow for more.